In this video, we're going to finish the Work Word Problems worksheet on the KutaSoftware website under the Algebra 2 tab. I'll leave a link in the description below so you know how to access this worksheet. And it's within the Equations and Inequalities section. It says, Alberto made a trip to his friend's house and back. The trip there took 3 hours and the trip back took 4 hours. So there is 3 hours, back is 4 hours. He averaged 9.8 miles per hour faster on the trip there than on the return trip. So what we need to do is find Alberto's average speed on the outbound trip. So it's his average speed on the outbound trip. That's going to be what our variable represents. So let's make this variable z. So his outbound trip took 3 hours, since outbound also means the trip there, so going there. And we're going to multiply that by z, because that's going to be Alberto's average speed. That's equal to the time it took to get the trip back, which is 4 hours, times the average speed of that trip. And he averaged 9.8 miles per hour faster on the trip there. So on the trip back, where it took 4 hours, he's 9.8 miles per hour slower. So this is going to be our variable z, so the trip there's time minus 9.8 miles per hour, since he's going a lot slower. So we'll have 3 hours times z, so 3z is going to be equal to 4 times z minus 4 times 9.8. 4 times z is 4z, and we're subtracting 4 times 9.8, which is 39.2. So when we subtract 4z from both sides, we'll get that negative 1z is equal to negative 39.2. Our final step is to divide both sides by negative 1 to get that z, Alberto's average speed on the outbound trip, is equal to a positive 39.2, and that's miles per hour. And if you're confused at why I took away 9.8 from z, that's because the trip there was 9.8 faster, so I have to take off 9.8 miles per hour since he's going slower. And that was slower on the trip back. In number 10, it says a jet left Tokyo and flew north at an average speed of 330 miles per hour. An Air Force plane left 1.2 hours later and flew in the same direction. So this north isn't very critical. We just know that they're flying in the same direction. The Air Force plane flew with an average speed of 396 miles per hour. It's asking us how long did the jet fly before the Air Force plane caught up. So our variable, let's use x in this case, is how long the jet flew. If the jet is flying at an average of 330 miles per hour, and he traveled for some unknown time x, that's going to be equal to the speed of the Air Force plane, which we know is 396 miles per hour, and the Air Force plane left 1.2 hours later. If x is the time that it took the jet to fly total before the plane caught up, leaving 1.2 hours later, the Air Force plane flew a total of x minus 1.2 hours. So now we're going to simplify and solve. We're going to distribute 396 to the x and to the 1.2 with subtraction in between. So we'll have 330x, and that's going to be equal to 396x minus 396 times 1.2, which is 475.2. So now we'll subtract 396x from both sides of the equation. 330x minus 396x will be negative 66x, and that's equal to negative 475.2. Next, we'll divide by negative 66 to get that x, how long the jet was able to fly before the Air Force plane caught up, is negative 475.2 divided by negative 66, which equals 7.2 and that is hours. So knowing this, you can see that 7.2 minus 1.2, the Air Force plane flew a total of 6 hours. However, we're just trying to figure out how long the jet flew, and that was 7.2 hours. Now let's move on to number 11. In number 11, it says a freight train left Washington traveling east for 7.8 hours before the diesel train. The diesel train traveled in the opposite direction, so one train, the freight train, is going this way, and the diesel train is going that way. The diesel train traveled in the opposite direction, going 17.1 miles per hour slower than the freight train, and it went that speed for 10 hours, after which time both the trains were a total distance of 941 miles apart. And it's asking us how fast did the freight train travel. So let's call that variable x. So how fast the freight train traveled is our variable x. The freight train left Washington traveling east 7.8 hours before the diesel train. We know that the diesel train traveled a total of 10 hours. So if the freight train left 7.8 hours before, then we know that the freight train traveled a total of 7.8 hours plus 10 hours. And we're looking at the speed that freight train traveled, so we're going to multiply that time by x. And we're going to add that to the total distance that the diesel train traveled, traveling in the opposite direction, which is why we're adding, and it went 17.1 miles per hour slower for 10 hours. So the total time is 10 hours. However, we're multiplying that 10 hours by our x, which is how fast the freight train traveled, minus 17.1, since the diesel train went 17.1 miles per hour slower. So x minus 17.1 is the speed of the diesel train, and x is the speed of the freight train. So multiplying their speed by the number of hours traveled will give us the total miles that each train traveled. And adding that together will give us the total miles apart, which is 941 miles. Now we're going to solve for x. 7.8 plus 10 is 17.8 hours. 17.8 times x plus 10 times x minus 10 times 17.1. So plus 10x minus 171, since 10 times 17.1 equals 171, and that is going to equal a total of 941. I'm going to combine my like terms, and I'm also going to add 171 to both sides. So subtracting 171 and adding 171 will give me 0. So I'll have 17.8x plus 10x equals 27.8x, and that's equal to 941 plus 171, which equals 1,112. So when I divide by 27.8, which is my total hours, I'll get that x, the average speed, equals the distance of 1,112 divided by 27.8, which gives me 40, and that's going to be miles per hour. So the freight train traveled 40 miles per hour, meaning that the diesel train was traveling 40 miles per hour minus 17.1 miles per hour, which is 22.9 miles per hour. So this is 40, and this quantity is 22.9. So you can see that 40 times 17.8 plus 10 times 22.9 will indeed give me 941. Now on to our last problem, number 12. Number 12 says an aircraft carrier left the Dania Pier and traveled toward Guam. 0.2 hours later, so our first piece of information, 0.2 hours later, a container ship left traveling 0.2 miles per hour faster in effort to catch up. So we know that they're going in the same direction. After 13.8 hours, the container ship finally caught up. So we need to figure out what was the aircraft carrier's average speed. So we know that the aircraft carrier traveled a total of 14 hours. And we know this because the container ship called up 13.8 hours and it left 0.2 hours later. 13.8 plus 0.2 gives us the total time that the aircraft carrier was traveling, which is 14 hours. We're finding the average speed of the aircraft carrier, so that's going to be our variable, and this time let's make that variable y. So traveling for 14 hours at a speed of our unknown y is going to be equal to the time that the container ship traveled, 13.8 hours, multiplying that by the container ship's speed, which is 0.2 miles per hour faster. So that will be y plus 0.2, since it's going 0.2 miles per hour faster than the aircraft carrier is traveling. So now I'm going to distribute 13.8 to the y and to the 0.2 and solve. So I have 14 times y equal to 13.8 times y plus 13.8 times 0.2, which is 2.76. Now I'll subtract 13.8y from both sides to get that 0.2y equals 2.76. Dividing both sides by 0.2, I get that y, the aircraft carrier's average speed, is equal to 13.8, and that is miles per hour. And that wraps up the work word problems worksheet. If you have any questions, please feel free to leave them in the comment section below. Also, if you need a problem further clarified, go ahead and comment, and I'll get back to you as soon as I can. And as always, give me a thumbs up on this video and subscribe to my channel.